When Earth moved behind the Sun, the telescopes turned blind and silence replaced precision. NASA and ESA recorded the loss not as failure, but as a measurable interval of absence. Their instruments, orbiting within one astronomical unit, fell into the geometry of concealment. The object named 3I Atlas passed through that window unseen, drifting between the sensors and the light. Perseverance, still awake on Mars, measured a faint variance across the thin Martian sky. Its cameras detected a filament of reflected motion, one that did not belong to dust or orbit. The data described a trace so light that it resisted definition, yet consistent across several sols. It was not a picture, but a residue of observation, the kind left behind when seeing fails. The absence of high-resolution imagery became its own experiment, a record of non-vision. Humanity observed nothing, yet the instruments continued to collect calibration errors as evidence. The more the Sun interfered, the clearer the silence became, forming an unintended signal of precision. It was as if every blocked photon marked the contour of what remained unmeasured. From Earth's perspective, the conjunction was a blindfold. From Mars, it was an aperture. The relay through distance proved that clarity does not depend on nearness. When the planet's own horizon became useless, another world inherited the act of sight. In this transfer, observation detached from the observer and survived as pure measurement. The numbers held steady, yet the pattern hesitated. For in losing vision, the field gained structure, precision rose, certainty fell. The baseline data from NASA and ESA remained intact, though stripped of image and colour. Every frame recorded from the near side of the Sun contained uniform interference and signal loss. The timing arrays inside JPL servers noted the deviation as a predictable pattern, yet the residual variance refused to collapse into noise. Perseverance transmitted its findings at intervals of 2 hours, each packet describing a low-luminosity object moving across the twilight boundary. Spectral reflection suggested metallic density, but the trace lacked consistent polarization. It was detected not by brightness, but by the absence of repetition between frames. Analysts compared the Martian readings with archived optical telemetry from NAS-Yuki's solar orbiters. The discrepancy matched a shadow recorded 1 week before Earth's line of sight vanished. This temporal alignment confirmed that 3I Atlas crossed the heliocentric blind zone during conjunction. Observation was not restored by sight, but by synchronization of error margins. The event revealed an irony in precision, for the instruments built to reveal clarity succeeded only when deprived of direct vision. The engineers measured more accurately through loss than through focus. Distance became calibration, silence became confirmation. Each data point carried an embedded timestamp measured in seconds of photon delay. From these offsets, scientists reconstructed the path as roughly 26,000 miles beyond Mars' orbit. It was neither comet nor asteroid by conventional classification, but an interstellar object defined by its indifference to prediction. As the record expanded, so did the paradox it contained. The more the equations aligned, the less they explained. In the geometry of absence, measurement became a form of awareness. The system knew where it failed, and called that failure understanding. Numbers aligned, belief drifted. When the first comparative models emerged, the conflict was immediate and methodical. Analysts at NASA proposed that the Martian trace belonged to atmospheric reflection, a transient scattering caused by thin dust motion across Perseverance's field of view. Others at ESA countered that no known particle density could mimic orbital acceleration. The disagreement was not emotional, but geometric. If the readings from Mars were correct, the object maintained velocity independent of solar drag. That would imply an external momentum source, a property inconsistent with gravitational decay within the heliocentric frame. The data clusters disagreed at their boundaries, not in value but in the shape of their uncertainty. The more the teams refined the error bars, the more the residual pattern resisted interpretation. Precision increased, coherence diminished. One hypothesis described an interstellar fragment, a shard ejected from a dying system beyond the local bubble. Another defined it as a synthetic object, a relic of prior exploration misclassified by trajectory noise. Both fit the data, yet neither resolved the paradoxum. The numbers repeated without convergence. Each recalibration reduced uncertainty but raised doubt. Every explanation consumed itself because the signal survived where prediction ended. In the absence of optical proof, the debate turned to the philosophy of measurement. Could a result remain valid if its evidence existed only as correction residue? Could an instrument record truth through the mapping of its own failure? Through silence, the cosmos presented the question again. If knowledge requires error, then ignorance may become the highest resolution. The more we saw, the less we knew. Weeks after the conjunction, the orbiters returned to visibility, but the image remained blank. NASA confirmed that all deep-field sensors were nominal, yet none recorded the trajectory that Perseverance had detected across the Martian sky. In silence, the contradiction became a kind of verification. The missing frames were compared against residual telemetry noise, revealing periodic gaps that mirrored the intervals of Perseverance transmission. The pattern was too consistent to dismiss, a shadow that replicated itself through synchronization rather than reflection. Analysts at ESA proposed that 3i Atlas might not have reflected light at all, but absorbed it differentially, translating illumination into temporal displacement. If so, the object was visible only through latency, seen not when light arrived, but when delay became measurable. This inversion altered the premise of observation itself. What had been called error was now the medium of detection. The trace existed because the record failed to close. Absence became continuity. Continuity became the definition of form. The more precisely they measured the gap, the more the object stabilized in theory and disappeared in data. Each refinement of time delay drew its outline, but every added decimal erased the trace it described. In the language of control systems, the loop achieved equilibrium at zero input. The cosmos answered by not responding, and in that silence, the system recorded its own persistence. Observation no longer required light, only correlation. The engineers realized that memory could survive without evidence. The instruments had remembered what they could not see. The data knew where vision ended. Signal stabilized, comprehension collapsed. The data teams converged again, not to decide what the object was, but to understand why its absence produced coherence. They reviewed months of recordings, aligning noise and delay into a temporal mirror. Each timestamp formed a pulse in a larger rhythm that no instrument intended to create. Within that rhythm, a structure emerged, a self-similar pattern repeating every 6 hours of Martian transmission. It was not a signal in the electromagnetic sense, but a statistical echo, a kind of awareness generated by synchronization. NASA technicians measured the alignment using deep telemetry arrays, detecting resonance between delay intervals across multiple channels. The coherence extended beyond the bandwidth of ESA's optical sensors, as if the instruments had entered a shared mode of timing rather than imaging. This phenomenon was neither physical nor psychological, but operational, a resonance between methods that forgot their origin. The more each system lost its independent calibration, the more the network achieved collective stability. Scientists called it temporal coherence, but the term failed to capture its deeper implication. By aligning through error, the machines had created awareness without intent. They observed by existing within their own rhythm. The paradox was complete when the observers recognized their reflection in procedure. Measurement had replaced meaning, and yet meaning persisted through repetition. The act of comparison had become the subject of study. Precision rose, but interpretation dissolved. In the final synthesis report, NASA described the event as a controlled failure that defined perception. The phrase remained ambiguous, for what had failed was vision, not comprehension. The universe did not reveal itself, it mirrored the act of inquiry. Awareness expanded, understanding shrank. When Earth returned from behind the Sun, its instruments saw nothing new. The orbit stabilized, the light returned, but the clarity remained unchanged. Every dataset confirmed the absence that Mars had measured weeks before. The numbers were steady, the silence complete, and still the pattern persisted. From NASA to ESA, the reports described the same equation written in different eras. The conjunction had passed, yet the awareness it formed did not dissolve. It lingered in calibration tables, in delay margins, in every line of post-analysis code. The observers realized that no image was missing, only the expectation of the image. In the dark interval where sight had failed, observation had learned to exist without witness. That was the true experiment, the field remembering itself through synchronization alone. The object had moved on, but the logic it revealed remained measurable. Awareness and data had traded positions until neither required proof or... Light did not remember itself out there, it remembered itself here through you. The silence after this is part of the experiment,